Well, hello. In this video, I would like to take a look at regular expressions, which are really powerful string pattern matching templates. These exist in almost every modern programming language. They're not just exclusive to Python. And in fact, you can study regular expressions all to themselves in all kinds of other separate books. And I'm going to make a recommendation about that as we start this video. But in this video, I would like to start by looking at regular expressions and the theory and what regular expressions do. And then in the next video, I will look at one particular problem that we can solve with regular expressions, and I'll write some Python pseudocode to get you close to that. So let's get started. All right, regular expressions. Nobody is neutral about regular expressions. People either hate them or love them. I think they are the best thing since sliced bread. So you can kind of guess which camp I fit into here. The title of this slide is, in fact, a regular expression. And so by the time we finish here, that'll make total sense to you. But again, the concept is pretty simple. That regular expressions are simply string pattern matching templates, and that's all they are. They've probably formed the basis of almost every search engine you've ever used. But there are so many other things that we can do with them. This is why they're really popular. They are not just exclusively a part of Python. They belong to almost every modern programming language today. So we can study and learn regular expressions no matter which language we happen to be using, and we don't need to know necessarily Python in order to do that. This is the best book on regular expressions by Jeffrey Friedel, called Mastering Regular Expressions. And Jeffrey Friedel writes that regular expressions in themselves have a general pattern notation, almost like a mini programming language. And what they allow us to do is to describe and parse text. Even if that's a little fuzzy, you can see here he says that there's additional support provided by a tool, that will be Python, for example. Using regular expressions, we can add or remove or isolate or generally fold, spindle, and mutilate all kinds of texts and data. And in fact, it's really true. He's not exaggerating. Regular expressions form a major part of a lot of data cleaning tools too, like OpenRefine, and you can even search for patterns of text in text editors using regular expressions. So learning how to understand them, how to wield them a little bit, even if you don't become a giant expert like Jeffrey Friedel, can be a really powerful tool for you working with programming languages. I just want to mention the history really briefly, not because you need to know it, but only to underscore the point that regular expressions are not part of Python. They form a kind of history. They have a history of their own, a trajectory of their own. And like many other things, some of these psychologists here, neuropsychologists like Warren McCulloch and Walter Pitts, and mathematicians like Stephen Claney, were some of the people who really invented regular expressions. And even if neuropsychology threw this away, computer scientists are a bit like dumpster divers, right? So neuropsychology throws away the idea of regular expressions, and the computer scientists are like, yeah, I think that's going to work out for us. So they picked it up, and it has become a major part of computer science today. It's very unlikely that you'll get very far using computers and programming without tuning through regular expressions. And again, just to repeat, a regular expression is just a pattern of characters, and we compare that pattern of characters to a string, and it either matches in that string or it doesn't. It's pretty simple in that regard. However, if it does match, we can start to do all kinds of things, like we can capture that text and extract it. We could modify it or remove it or replace it. We could swap it around. We can do tons and tons of things with it and use it to, for example, clean dirty data, all kinds of things like that. Now, when regular expressions read those patterns, we have to understand, firstly, I think, that there are just two different kinds of characters in those patterns. There are literal characters and there are meta-characters. The literal characters are pretty simple. Even though this sounds dumb, they match themselves. So if you put the word banana into the Google text engine, right, the Google search engine, you're going to find pages that have the word banana in them. And that's what we mean when we say that their characters match themselves. So if there's a lowercase a, you're just looking for a lowercase a, and there's a lowercase a in your text, that counts as a match, right? Capital X matches a capital X. And so remember, because text is case sensitive, and so are regular expressions, a lowercase d and an uppercase D are actually different characters. Unless we specify otherwise, those two characters don't match each other. Now, we can tell the regular expression that we think that they should, but unless we specify otherwise, lowercase letters and uppercase letters are different. Now, the metacharacters are characters that modify a group or one character. So they qualify the kind of match that we're about to get. So common metacharacters include things like a dot or a period. The dot matches any character whatsoever. It's a kind of a wild card character. So these modifiers or these qualifiers are characters that, to be honest, we just have to memorize. Unless we specify otherwise in a regular expression, a meta character or a qualifier character is always a qualifier. And so we have to do something special if we want our regular expression to match a literal period or a literal question mark or a literal star or a literal period, etc., etc., etc. Now, here's why regular expressions are often hated by everyone, because those meta characters have to be memorized. There's just no other way around that. Now, when we start reading regular expressions here, I will read out what the meaning of that regular expression is. And so when you learn to read regular expressions, I encourage you to do the same thing, because instead of reading that as a dot or a question mark or a star, we will read that as any character or optional or as many as possible, including 0, or the plus, as many as possible, but at least once. And so those meta characters have to be memorized because they modify the thing that goes before, whether that is a single character or a group of characters. It doesn't particularly matter. Now, one quick thing here. I'm going to put my regular expressions in little slashes here. Now, when we get to Python and how to write regular expressions in Python, we don't need those slashes, but I want a way to be able to distinguish what constitutes the beginning and the end of a regular expression. So I'm going to use slashes, but by the time we get to Python, they're just going to be strings, and so we'll use things like quotation marks. But I just wanted to mention to you why I'm going to put slashes in here. And I know it's a little confusing that in Python we don't need those, but we're going to use a website here in a little bit, and you'll see that the slashes are in there too. All right, so let's take a look at this regular expression. This is, you think, is cat, maybe, but it matches in the following strings, right? So remember that literal characters match themselves. So when I read this as a literal C, followed by a literal A, followed by a literal T. And it matches here in all of those strings, right? So from scattering papers to authentication to the pumpkinification of society, etc., and a whole bunch of words down at the bottom that I can't even pronounce. And as I noted before, remember that these are case sensitive. So this CAT does not match Catherine because that's capitalized. Now again, I can tell the regular expression to match otherwise, but I haven't done that here, so it is in fact case sensitive. Now the other part about this that I really want to emphasize, and the reason that I use CAT as my example, is that we can't think about the regular expression as a cat, because what it puts in your head is a fuzzy little four-legged animal that is perhaps mythological. But if we think about it more literally, more syntactically rather than semantically, it is simply a literal C followed by a literal A followed by a literal T. Thinking about that in terms of a literal whatever, rather than a kind of semantic context or semantic meaning like a fuzzy little animal, is what we really need when we read regular expressions. We have to be the computer. If we disconnect our brain from every meaningful thing, that's what's really important. We have to start to think about this as patterns of letters that follow one another. And as long as we can think about it on that really superficial surface level, that's the clue to getting better at regular expressions. All right. Well, let's look at some metacharacters, and then we're going to go on, and we're going to go on to one particular website where we can actually play with regular expressions, and it's quite a great sort of sandbox for us to learn how these things match and how they work. So here are a list of metacharacters. This isn't all of them, but these are the ones that are the most common and the ones that you really have to start to memorize right away. Some of these we've seen already, especially that one down at the bottom, the dot or the period. The dot and the period, whatever you want to call it, I'm going to call it a dot, is a metacharacter that matches anything. So it's kind of a wild card in that regard. Now, as we'll see later, this is maybe a little detail. It doesn't match a new line character, and that may be important to us later. But this period or dot matches any character whatsoever. Now, we can modify the behavior of that or any character with some of these other metacharacters. And let's start with the plus. I should put these in a different order. The plus means that we want to match that preceding thing as many times as possible, but at least once. And that's the important part about the plus. So every time I see a plus in a regular expression, I'm going to read it as many times as possible, but at least once. The similar one is the star, which is up at the top, or the asterisk, which is match it as many times as possible, even if that happens to be 0 times. So as many times as possible, including 0, is how I'm going to read that star every time I see it. The question mark means that the preceding character, or maybe a group, is optional. So maybe it's there, maybe it isn't. Sometimes when you read this in a book or online, you'll see it matches 0 or 1 times. That's okay. But I think just thinking about the question mark as meaning optional is a little bit clearer. Now, there are a couple of others here, the parentheses and the square brackets, and I'm going to come back to those a little bit later. But the parentheses creates what we call a group. And groups are really powerful in regular expressions because that's what allows us to capture text out of a match. And so if we're doing things like a web scraper maybe, or we're doing some data cleaning, we need to extract some information. We're going to use parentheses to do that. And we're going to see that in a little bit. The square brackets, and we'll come back to these here in a little bit too, create what's called a character class, and I can swap in and out different kinds of characters there, and we'll see how that works in just a minute. Quick more metacharacters before we do some text matching. A caret, the upper arrow caret there, matches at the beginning of a string. And we will see that when we get to the website and start playing with regular expressions. And we think of it sometimes as an anchor. That anchors a regular expression to the very, very beginning of a string. The $sign does the opposite. It anchors a regular expression to the end of a string. And so we can use that caret, that up arrow caret and $sign to make sure that we match at the beginning or match at the end, right? The curly brackets match a number of times, so we can qualify something. So if I put the number 2 inside of curly brackets, what that says is that that preceding thing should be matched 2 times in a row. And we can put ranges in there as well. So curly bracket 2, 4 says match that as little as 2 times or as many as 4 times, right? So 2 or 3 or 4. And we can even leave off one of those. So if we do curly brackets 2, nothingness, just a closing curly bracket, that says that we should match that thing at least twice. So for example, we want to see if we've misspelled any words that have, say 3 A's in them, right? We can put the literal letter A followed by curly bracket 3, curly bracket, and the regular expression will try to find 3 A's in a row. The pipe character, which is usually over on the right-hand side of your keyboard somewhere, sometimes you have to shift to get it, means or. So it's either the first thing before that or it's the second thing after that. And we'll see that, especially common in groups. All right, let's look at a couple of examples, and then we're going to go to a particular website and we'll play with this a little bit. So again, when I see a regular expression like this, I don't read it as cat because that puts my mind and my brain into semantic fuzzy animal thinking, and that's not what I need. So I read that as a literal C followed by a literal A followed by a literal T. Now I can start adding some meta-characters. This is a C followed by an A followed by a T followed by an optional S. So that question mark modifies the one character immediately before the question mark, which is the S. And so the S can match, or we could match without an S. Both would be fine. This says that I have a literal C followed by any character whatsoever, followed by a literal T, followed by an optional S. So this could match cat or cut or caught, right? All kinds of words, different kinds of vowels could go in there between that C and that T. This one says that I need to match a literal C followed by an A, followed by a literal T, followed by any character that repeats any number of times, including 0 times, but please as many as possible. So really expanding the meaning of that star character. But it really means any character any number of times, as many as possible, but even 0 would be fine. And that's slightly different than the plus, which plus means any number of times, but at least once. So this is a C followed by an A followed by a T, followed by as many S's as possible, but at least one, is what that one means. Now here's one that we'll play with in just a couple of minutes when we get to the website. There's a parenthesis here, and that is a meta character that saves a group, or sometimes we call them back references. So I'm looking for a group, which is any character whatsoever, at least once, and as many times as possible. And I'm going to save that off into a group, and that's a more sophisticated thing we can do, especially if we're scraping data, right? Followed by a literal space, right? Don't skip those literal spaces. We've played with strings a lot in this class. So remember that those spaces matter. So this is a group followed by a literal space, followed by a literal C, A, T, and an optional S at the end. All right, so here's what we're going to do. I want to look for some cats and dogs in a text. So feel free to invent a few sentences of text that have some cats and dogs. Here's a little tiny webpage that I put up in case you want to surf to that URL and just copy that text. I'll show you what that is in a second. But then what we're going to do is go to regex101.com, and that's where we're going to play with regular expressions so that we can see how they start to match. All right, here I am in the browser. I just need a little bit of text, and I'm going to copy and paste this. This is up on our Sandbox server. You're welcome to use this, or you're welcome to make up your own. You'll notice that I have some DOG words and some CAT words, and I have a few digits in here as well, and that's what we're going to play with. So I'm just going to copy this, and then I'm going to move over to regex101.com. And you'll notice there's a big window down here, down at the bottom, and that's where I can, as it says, insert your test string here. And so I'm just going to paste my text down here. And now you'll notice up at the top, I can put my regular expressions into the window up here on the top. And that's what we're going to play with. And then the matches will highlight down here. You'll notice over at the left that I have Python clicked. And you'll notice that there are quotation marks here at the beginning, and these are the delimiters that we're going to be using in Python. If I change that to the, say, Perl compatible regular expressions or the PHP ones, you'll notice that the delimiters turn into slashes, and that's why in my slideshow a few minutes ago I used some of those slashes. But I'm just going to put that back on Python. So what I can do now is type my regular expression up here, and if I put in the literal letter C followed by A followed by T, you can see which parts of that string down below get highlighted. It's really nice because it just alternates a light blue and a dark blue, so the color of the blue doesn't really make any difference to us at all. It's not something that we need to pay attention to. But you'll notice that the literal C, literal A, literal T move through this string, and I get both cat, the fuzzy four-legged animal, and things like vacationing or educated, because I'm just matching the literal letters. And again, I know I'm repeating myself. This is why we have to start to think syntactically or superficially rather than semantically or meaningfully. Now, if I add a literal S to the end of my regular expression, you'll notice now that I just get the CATS match. Vacationing, educated, go away. I don't have those anymore. If I add a metacharacter that describes S in particular, if I add a question mark, now my regular expression says a literal C, literal A, literal T, followed by an optional S. And now you'll notice that I get all of them again. I get vacationing, I get educated, and I get all of the CATS, so the plural fuzzy animals, right? Now, I can do the same thing with dog here, D-O-G, and I know I'm playing with animals, and maybe at some point now I need to get away from animals. But D-O-G matches in the following words. All of these are fuzzy creatures as well, except this dogmatically that is sitting in here. Now, if I add an S, and I need a literal S at the end of that match, now you'll know that it matches only twice. My dogmatically ceases to match. My one dog down here ceases to match as well. If I make the S optional, now you'll see that I get all of those matches back again. If I make that optional, turn that from optional into required, but one or more, now you'll see that they go away as well. If I look for other kinds of word combinations, I can look for something like maybe a literal A. Those start to show up everywhere. Is there anywhere where there are two A's in a row? And you will notice that there are not. So I could look, for example, for a literal L, and you'll notice that there are literal L's everywhere. Are there any places where there are two L's in a row? And the answer is yes. The word dogmatically has two L's in a row. Let's take a look at that dot metacharacter. So again, we already looked at this. If I find an A, they are everywhere. If I look for two A's in a row, I don't find them. No matches. But if I look for A followed by any character whatsoever followed by another A, you'll see that that pattern occurs in two places. Vacationing, where I have an ACA, and the word away, where I have an AWA. So again, memorize those metacharacters. That is A followed by any character whatsoever followed by another A. Now, I can do fun things like qualify how many times that dot metacharacter can occur. So, for example, if I put in, say, 2, 4, you'll notice what I get now. This is an A followed by either 2 or 3 or 4 occurrences of any character whatsoever followed by another A. And you'll notice that it starts there in cats and dogs, where the 2 to 4 different characters are a T and an S and a space. So there are 3 characters between those two A's. Dogmatically has a T and an I and a C, so there are 3 characters there. Ran away has an N space, and I guess that's it, although it's greedy. So it's going to match N space A, W, and then another A. So it's matching 4 characters there. We haven't talked about greedy and non-greedy, but that's a greedy match right there. Let's do a little more chalk talk here, and then we'll come back to Regex 101. I mentioned briefly that we can create what's called a character class by putting some characters inside of square brackets. This character class here is a series of vowels, E, I, O, U, sometimes Y. And what a character class says is match one of those things. So either an A or an E or an I or a U or I lost my track color, but you know what I mean. So match if any one of those members happens to be found. So what we could say is, does the character class A-E-I-O-U-Y match against cat? And the answer is true, it does, because cat has an A in it. So it doesn't have to match all of those letters, it just has to match one of them. The same thing here, A-E-Y against C-T, but that one is false because the string C-T does not have one of those vowels. So that one doesn't match for us at all. Does the A-E-I-O-U, sometimes Y, match against the string cutting? And the answer is true, it does, because it matches that first U. Now sure, there's an I in there, but that doesn't matter. We only need to match on one of those. Now, if I needed to match more than one vowel, I can actually put a qualifier on the end of it that matches a certain number of them in a row. So for example, does the character class A-E-I-O-U, but any one of those characters, or any, I should be more precise, any member of that class 3 times in a row? And if we match that against the string I, it is true, because E is a member of that class, Y is a member of that class, E is a member of that class. The same thing, colloquium, that one is true too, because there's a U and an I and a U. So some member of that class occurs 3 times, right? I know that's a little hard to describe. There doesn't have to be a repetition of the same character. It just has to be one member out of that class occurring 3 times. So gracious does that too, right? So I-O-U, all of those are vowels in that character class. Same thing against Aliard, right? So the E, this one is a weird one. The E and the Y and the A match. Now in that case, right, Y isn't a vowel, I know. So if we wanted to look for purely, exclusively only vowels, we'd probably take that Y out of there. But you can see how this matches. Again, we have to be superficial. We have to be syntactic rather than semantic, right? So does that 3-part match against canoeing? Sure does. There's an O and an E and an I, so that works. All right, here's what I want, because we're going to go back to those dogs and we're going to play with dogs and cats here a little bit. Now, I can create character classes that signify digits, for example, or word characters, other kinds of white space. So digits, we all know 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in fact, I can create a character class of digits in regular expressions. And the cool thing about character classes is that character classes recognize sequences. So one traditional way that I could define a class of digits is to say it is all the characters from 0 all the way to 9. That's good. I can do word characters too. So here I have a whole bunch of sequences. I have the sequence from capital A to capital Z, lowercase a all the way to lowercase z, all the digits from 0 to 9, plus the goofy underscore character. And that constitutes a character class. Now what's interesting about this one, if you've done any computer stuff, these are also, interestingly, the legal letters that you can put into a programming language variable name. So there you go. So does that tell you that under the hood, when Python is looking at your code, that it's using regular expressions? Answer, yes. Now, white space is another one that's really interesting. We've already looked at the blank space, but we know too that there are things like tabs, there are new lines, there are carriage returns, which are R's, there are form feeds, there are vertical tabs, there's all kinds of crazy stuff that we probably don't even use very much. So one of the things we can do that's interesting for cleaning data is that we can start to create character classes on our own. Now what you'll see here is that these character classes are created so commonly that the regular expression community has built shorthands for those character classes. So I could build a character class of digits on my own, but \d does the same thing. I could build a character class of word characters on my own, but \w does the same thing. And again, same with white space. I could build it on my own, but it's pre-built into the regular expression engine, and \s is any of those white space characters. Now, remember, I said that every character literally matches itself unless we say otherwise. This is how we're starting to say otherwise. So a D matches a literal D. But a \D, the backslash gives that D superpowers. It gives it a superpower cape. And it turns now into a meta character. And that meta character of \D is a shorthand or a shortcut for representing the class of digits. Same with a W. The lowercase w, just as a literal W, it matches itself unless we say otherwise. And by saying otherwise, we give it a superhero powers, we give it that backslash, and then it turns into a shorthand or a shortcut for this character class of word characters. And same with \S. So what we're going to do here in just a minute is we're going to play with that \D character class when we get back to our cats and dogs. But what's cool, really cool, I think, about character classes is that we can negate them. And you'll notice that what the shorthand does is to capitalize that letter. So \D is any character that is not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. \W is any character that's not cap A to Z, lowercase a to Z, 0 to 9 underscore. And anything that's not white space is \S. Now, we already talked about that caret character, and that caret character, unless you put it here inside a character class, means root that or anchor that to the beginning of the string. But inside a character class, it is a negation symbol. So that kind of traditional definition of not digits, these square brackets says I'm creating a character class. That up arrow caret says negate everything that is to follow. That is to say not 0 to 9. And so the not word characters are character class square brackets, not cap A to Z, lowercase a to Z, 0 to 9 underscore. Anything that's not those things. So it's really, really easy to play with character classes and negated character classes in regular expressions. Quite powerful. All right, back over here in regex 101, let's start looking for some of those character classes. Let's look for some digits. So I can put in a character class here of 0 to 9, and you'll notice that we start to pick up all of the digits in that text down below. But there's the shorthand, \D, which gives us exactly the same thing. So let's imagine that I'm writing some Python and I would like to extract the number of cats mentioned in this giant text. Well, one of the things that I can do is I can craft my regular expression to find a digit followed by a literal space, followed by a literal C, literal A, literal T, I don't know, maybe an optional S at the end. And you'll notice that 5 cats and 2 cats are highlighted here. Now, if I want to capture that in Python, the one thing that I'll need to do is to put that into a group. And so I can put the digit character class into parentheses. And now you'll notice over here on the right in my explanation, this is a capturing group. And down below here, you'll see that the full match is in blue and the group match is in green. We saw that a little earlier, didn't we, in our slideshow? But so you can see now 5 cats, the space CAT optional S, is part of the full match. But the thing that I'm capturing is the 5, the digit 5, and that is my group. Same down here for 2 cats. Now, what happens if I do this? What happens if that's 23 cats instead of 2? Well, now what you'll notice is the 2 is not matching anymore, but the 3 is. And in fact, I can confirm that over here on the right. The full match there is 3 cats, but my group is only the 3, and I want the 2 as well. So obviously what I need to do is I need to go back, and instead of searching for one digit, I need to search for one or more. So my group now is one or more digits, and you'll notice that I am in fact picking up both the 2 and the 3. That's exactly what I wanted to have happen. So let's read this out loud just to see that we know what it means. So I see that left-hand parenthesis and I say, okay, this is a group. I am capturing a group of digits, one or more, but as many as possible, followed by a literal space, literal C, literal A, literal T, optional S. So my full match, as you'll see, is 5 cats or 23 cats, but I am capturing into a group the number itself. Now what I could do in Python is take that number out of the regular expression and then start to add those up in a loop. Well, let's just do the same thing with dogs here. So I'm going to go back and do DOG. There are my dogs. And so now I've got 3 dogs and 1 dog. And again, I'm matching here because the S is optional. If I take that question mark off, the S is not optional. It must be there. So the 1 dog down here fails on my match. If I add the question mark back, or even a plus. Nope, sorry. The plus doesn't match. That one has to be a question mark. Well, what if in Python I was trying to figure out how many cats and dogs there are together? I can do that in regular expression too. What I need to do is to change my regular expression match so that it can alternate between either cats or dogs. Now, the way that I do alternation is that I have to create a group, and then I use that pipe character inside in order to match. So what I can say is cat, let's make that with an optional S, and then I put in that pipe character, and then I have little DOG optional S, and they'll make that be a group. And now what you can see is how that matches, and the color coding really helps me here, right? So I'm matching in my first group 1 or more digits, followed by a literal space, followed by either CAT optional S or DOG optional S. And so now you can see how my groups are matching. I have a full match of 5 cats. Group 1, my first set of parentheses, are the digit itself. Group 2, the second set of parentheses, are cats. Now, here's a little trick about how you can figure out what's going to show up in group 1 or group 2, is that you count the number of left parentheses. And so whatever you're trying to match, figure out how many left parentheses it takes you to get there, and that's your group number. Now, why is the group number important? Well, because in Python, I can extract that captured text by group number. So let me read this one again. This is first left parenthesis. So therefore, first capturing group of a digit, 1 or more, and as many as possible. That is followed by a literal space, followed by a second capturing group. That group consists of either CAT optional S or DOG optional S. And again, captured into group 2. All right, well, that's all we're going to do for regular expressions in this slideshow. But in the next one, we're going to pick up this meme that floats around the internet constantly, which is that facetious is the only word that uses all of the vowels in order, A, E, I, O, U. This is a perfect example of regular expressions. So we'll do that in the next video. Thanks.